Guys, welcome back. Last video we talked about multiplying whole numbers. We're going to talk about dividing whole numbers in this next video, but first I have a real quick review I would like you to do. So go ahead and pause the video, write down these two problems and solve. And I want you to start getting in the habit of working under the pressure of time, because that's what you're going to be experiencing when you take the AFCT. So pause the video, maybe take out your phone or something and set a 5-minute timer or a 3-minute timer and just get used to the pressure of working under time. So go ahead and do the video and I'll come back and we'll discuss the answer. Okay. Alrighty, so here are the answers you should have gotten for those two review problems. This was a tricky one. You really had to take your time. There was a lot of carrying and you really had to keep your work organized. So you should have ended up with 4,082,157, and for this one you should have gotten 28,569. If you didn't get these answers, go ahead and pause the video and just check your numbers by line. So make sure that your digits on the page match to mine. And again, most of our mistakes come from small, silly computational errors. So just go ahead and see if you can find your mistake, and then we'll move on to division. All right, so dividing whole numbers. Again, same as in multiplying whole numbers, knowing your multiplication facts will help you and make this process so much faster. So again, make sure you download those apps or get some flashcards and start working on your multiplication facts. Okay, so we're gonna set up our problems for long division. You've noticed I've got my math sentence here, 324 divided by 9, and I've got my little box here, which is how I set up my long division. I just want to talk real quick about which number goes where when you're setting up the problem. It's super important that you set it up the right way. You need to know that the first number always goes in the box, not the bigger number necessarily, because when we start dividing decimals, it's gonna be different, all right? So just remember, the first number always goes in the box, and the second number is on the outside of the box. So go ahead and pause the video and get all your problems set up and put the right numbers in the correct boxes. I know when I taught the class that some of my students who grew up in different countries learn a different way of doing division, and it's a little bit flip-flopped. So normally it looks like this, and I believe that the first number goes on the outside of the box and the second number goes on the inside of the box. If this is the way that you learned, by all means set it up this way. There's no reason for you to have to go learn a new way unless you like this new way, okay? Unfortunately, I was never able to master this format, but it's basically the same process. It's just the numbers go in different places, okay? So if this is your way, you should be able to follow along this way and get the same idea of where to put your numbers for this method here. What you're going to ask yourself first is, how many times does this number on the outside of the box go into the number on the inside of the box? But we're going to work one digit at a time. So let me just cover it up here. So we're going to start by saying, can 9 go into 3? Well, no, 9 can't go into 3 because 3 is smaller than 9. So then what we get to do is reveal a second digit. 9 can go into 32. Sure can. How many times can 9 go into 32? It can go in 3 times, because 9 times 3 is 27. So you're going to put the 3 above the last digit that you used, so it would go right above the 2. And it's really important, again, that you keep your work organized and put the right digits in the right place, because the last thing you want to do is mess up your decimal places. The first thing I asked myself is, how many times can 9 go into 32? We said it can go in 3 times. The next thing I'm going to do is multiply. 3 times 9, which is 27. Okay, next thing I'm going to do is I'm going to subtract. 2 minus 7, can't do that. So I'm left with 5. Now we start the process all over again. And I have a little acronym that I used to give to my kiddos when we were working with long division for the process, and it's called HMS. And one of my students told me that she thinks it stands for Hobbits Make Socks, but it's an easy way to remember the acronym. We say how many times, we multiply, and then we subtract, okay? So 9 can't go into 5. So what we get to do is we get to bring down this 4. 9 can go into 54. It can go in 6 times. I'm going to do 6 times 9, which is 54. I'm going to subtract. And because I have a 0 remainder and I have no more digits left here, I know I'm done. So my answer is 36. All right? I know it's kind of a lot of steps, but it'll get faster once you do it over and over again. Let's go ahead and do this problem. You should have had 1296 on the inside and 81 on the other side. Okay, so 81 can't go into 1, can't go into 2, but it can go into, can't go into 12, but it can go into 129, and it can go in just one time. 1 times 81 is 81. Now I subtract. 81 cannot go into 48, so I have to bring down the 6. This is where it starts to get a little tricky. Sometimes with this, nobody knows exactly off the top of their head how many times 81 goes into 486, so you might just need to do a little bit of guess and check off to the side. So I'm just going to do 81. I'm going to start with 81 times 4. And see if it goes in 4 times without going over. It can definitely go in more than that. So let's try 6 times. There it is. So 81 can go into 486 6 times. We already know that 6 times 81 is 486. I subtract, I have a 0 remainder, so I am done. Okay, moving on to the next one. 577, 8 will go in the box, 18 on the outside. 18 can't go into 5, but it can go into 57. Let's do some work off to the side. Let's do 18 times 4, see where we go. 4 is 32. 4, 72. That's too much. Let's try 3 times. 18 times 3. There we go, 54. So 3 gonna go above the 7. 18 times 3 is 54. 57 minus 54 is 3. Okay, 18 can't go into 3, so we're going to bring down the 7. 18 can go into 37. Well, I know 18 times 2 is 36, so I know it can go in 2 times. 36. 1 left over. I'm going to bring down the 8. 18 can go into 18 1 time. Okay? 0 remainder, and I'm done. All right, go ahead and let's do number 4 together. This one has a little trick to it, so we need to talk about it. All right, so 1900 in the box, 95 on the outside. Okay. 95 goes in, can't go into 1, can't go into 19, but it can go into 190 2 times. That would be 190. All right, I have a 0 remainder. Does that mean I'm done? No, it does not. As you can see, there is still an empty space up here that needs to be filled. Okay, so if you have an empty space here with a 0 remainder and you have nothing but zeros left in the rest of your number to work with, you can assume that this number here is going to be a 0. Okay, so don't think just because you have a 0 left that you're done. If you still have digits left here to work with, you are not done. You need to fill in the empty space, because remember, we're going all the way, we're going all the way to the end of the number in the box. So you can see we have a digit right above the last digit that we worked with inside of each of our boxes. Okay, so be very, very careful, because if you say your answer is 2, it's going to be wrong and it's going to mess up your answer. Okay, so let's do number 5. I'm going to do it silently and you work it on your own. Alright, so you should have gotten to a similar situation that we had over here. You have a 0 remainder, but not all of your spaces are filled in. So we're going to add a 0 right there. And that is your answer. Alright, I hope you enjoyed this video. If you have any comments or suggestions about how I can make any of these videos better, please let me know. Go ahead and check out my next video where we're going to start working with decimals. All right, see ya.